Hello and welcome back. So in our previous segment we were talking about temperature. In this segment we're going to talk about how light is related to temperature. So I want you to think about an electric stove. And so with the electric stove off, what we're going to do is slowly turn the dial, and what we want to know is what are some properties that are going to change about the stove. Okay, so you've got a couple. All right, first thing that you might notice is that you're feeding more energy into the stove. Another thing you might notice is it's starting to get hotter, so it's starting to give off more energy. Another thing that you would notice is the color is changing, so that the first color that you're going to see is kind of a reddish color, and then it turns orange, and then you might be able to get some yellow on it, but that's about it. Okay, so those are some colors. And then what about the brightness? Did you notice that the red color is very dim, and then as you continue to increase the power to it, increasing the temperature to it, you should be noticing that it's a dull red, and then it's a brighter orange, and then finally it's an even brighter yellow, so that the color is changing. So let's see if we could graph that. What would it look like? So what scientists do is that they make a graph of the wavelength of the light being emitted, and then also versus the brightness. So this will be the brightness over here, and then the wavelength is going sideways. And so for a small temperature, so let's start off with the low temperature, at first you're only feeling the heat being given off. So the stove still looks like it's black, but yet it's giving off heat. And what kind of light is heat? That's going to be infrared. So let's put a dot over here, and notice that I'm putting the dot down low because it's not very bright. As a matter of fact, it's black. Okay, and then the wavelength that it corresponds to would be, I'll just put IR for infrared. So it's going to be giving off heat. Okay, then you start to see the red. Okay, so now let's go over here and let's say that this is the wavelength that corresponds to the color red, and so you're going to be able to see that. So I'm going to put it up a little bit higher than the infrared because it's now visible. And then we're going to take the orange, so let's put orange next to red, and then it's going to be higher still. And then finally let's put yellow over here if we could see it, and we're going to put it up even higher, so that we're ending up with kind of a curve. You can see there it is, and you see that that curve is going upwards. And so you might think that the stove is only giving off one color of light, when in fact it's not. It's giving off a lot of different wavelengths of light. So let's draw in what's really going on here. Let's start with the infrared. That it turns out that in the infrared part, that's where it's giving off most of its energy. So we're going to draw a curve that does something like this. So you see that it makes a hump there at the infrared part. And so all of these different wavelengths of light are contributing. But you see that there's might be just a tiny bit of radio's on this side of infrared. And so there might just be a tiny amount of radio, but a little bit more of infrared. And then you can see that there might even be some visible over here, but it's just that it's so small that you're not going to notice it. So again, most of the light being emitted by the stove is where this thing is at its maximum, and so that's in the infrared part of the spectrum. So let me just go ahead and color this in so that you can see all that. Okay, now so this represents a low temperature, so I'll put a small t. Now let's go to a higher temperature, and we said that it turned the color red, but again, it's not just red. So it's going to be multiple wavelengths that are contributing, and then when you add all those colors together, that's why you see the color red. So let me illustrate this one with a different color. And I'm going to make my hump, but do you notice that the hump is higher than it was before? And then also, do you notice that it shifted in that direction? So it's shifting towards the gamma rays. So up here you got the gammas, and then over here was the radios. And so let me just shade this one in. Okay, and then those, that would be the curve that would correspond to the color red. Okay, now can you figure out what it would do for orange? So for orange, again, we're going to make that hump-shaped thing. It's not symmetrical. I'm making it look like it's symmetrical, but it's not. And so there is the orange. You see it's all getting all messed up there. But that's what the green is going to look like. And then we could also do it for yellow, and what do you think it would be? It would be taller still, and again, it would be shifting in that direction. Okay, so there is a simulation that we can do. So if you wouldn't mind, go to the internet and then go to PhET, and then go to Blackbody Spectrum. So find that simulation on your computer. Got it? Okay, remember you can always pause me while you're doing that. Okay, so when you get there, you see that second picture next to the pot on the stove? That's what it's going to look like. And what you can do is by manipulating the slider, you can change the temperature. And then what I want you to see is at a low temperature, you're getting a curve that is low. And then as you increase the temperature, you'll see that the curve gets taller and taller, and the curve is shifting in that direction towards the gamma rays. And that's what I want you to see. So we're going to call these things black bodies. An object that can absorb all colors of light and can also emit all colors of light is going to be called a black body. So like, for example, a black piece of paper absorbs all wavelengths of light. That's why it's black, because none of the light is then emitted by that black piece of paper and then goes into your eye. Okay, likewise, a black body, once it gets hot, emits all wavelengths of light. So just like this hump here is emitting some light over here, and then some light over here, and then some light over here, it can absorb all wavelengths of light, and it can also emit all types of light. So the stovetop isn't a perfect black body, but it's pretty close to one. The sun is a better one. So the sun emits all different wavelengths of light, and theoretically it could also absorb all wavelengths of light. So I wonder if there might be a formula or formulas that would summarize all of this information about the brightness of the light being emitted and the color of the light being emitted and the temperature of the object. Well, I bet you there is. So if you will come back in our next segment, we want to talk about the black body radiation laws. So I'll see you then.